Morning. How's everybody doing today?
Well, thanks.
Awesome. Hey, no, you guys have a lot of options, a lot of great sessions going around, so really appreciate it. If you guys are in the room, really appreciate you guys being here. And the folks who are going to see the recorded session later, thanks for your time to view this. So today, I think we're going to go over some of the latest VMs and the infrastructure that we're working with our Microsoft team here. The goal here is for you guys to walk out with some insightful actions as to how you can leverage the general purpose, the compute optimized, the storage optimized instances to really go modernize and migrate or modernize wherever you are in your migration journey or transformation journey. Today, joining me are Stefanie Lemon.
Morning.
Thank you, Stefanie. Group Product Manager in Azure, and Mayunk Jain. He leads the core compute. He leads the app services. He's going to talk a lot about it. So thank you for joining me.
Thanks for having us.
It's great from infrastructure to IaaS to PaaS and SaaS services. So thanks a lot for joining me. And let's get started.
Absolutely.
Yeah? Awesome. So if you got a chance to stop by the AMD booth, you might have already seen our deep partnership with Microsoft. And it goes from gaming, so all the Xboxes that you and your family enjoys playing, we work closely with Microsoft on getting that optimized and the best out in the market. But you go beyond that to Copilot plus AI PCs. We partner very closely with that team in Microsoft as well. Now, when you come into the data center and server world, both on-prem and hybrid solutions with Azure Local, they run on infrastructure that Stefanie and team kind of designs and works with us very closely. And now, finally, in public cloud, a lot of VMs, general purpose, HPC, and specialty VMs, we again work very closely with Stefanie and team to go get those designed in. Hundreds, if not thousands, of AMD engineers and business folks and product folks work closely with Microsoft engineers and product teams, including Stefanie's, and really go bring this full range of solutions to help you with your migration and modernization journey. All right? So I'm going to say a few words, and Stefanie, please feel free to add in, right? Our partnership with Azure started way back. Azure was one of the first, or actually the first hyperscaler to put our EPYC CPUs into cloud, and it all started with initially a storage optimized LSV2 instance. That was built primarily on initial Naples kind of product, which was our first EPYC series. And then from that point on, from every year, we have added more and more VM shapes and configurations to the offerings in Azure. In 2018 timeframe, we added those, and if you look at it, we did the V4, the DAEA series, which is the general purpose VMs, from Naples to Rome to Milan. Late last year, we released the 6th Gen DAEA series, which was based on the 4th Gen EPYC codenamed Genoa. And we're very excited, and we're looking forward to, and Stefanie will talk a little bit more in the end about the V7 engines that are coming. Now, I'll be remiss if I don't talk about Microsoft and Azure also being the first hyperscaler to put our MI, the Instinct series, for AI inference into Azure, and we have a lot of great customers together, both internal and external. So we have a full 360-degree partnership from gaming in Xbox, the specialty CPUs that we build there, to general purpose VMs, to HPC VMs, going into AI compute with MI300X. And we're also looking to grow that partnership. 𝗦𝗲𝗀𝗀𝗶𝚀 announced in her keynote earlier about Microsoft's intent and how we are closely working on the MI450 series, which is our next-gen GPUs for AI inference as well as training. Stefanie, you want to add something here?
Sure, thank you. Yeah, it's been a wonderful partnership over the last 8 years. We really appreciate the collaboration that we've had. And you can see from the range of offerings within our VM portfolio that AMD EPYC is providing value across a wide range of workloads, general purpose, memory optimized, HPC, AI, it's quite the range. So we're looking forward to another set of offerings very soon on general purpose and another partnership, going forward.
Awesome.
Thank you.
Thank you, Stefanie. And Stefanie will be back to talk a lot more about how Azure is adopting these infrastructure solutions for both the first-party services and also for public cloud. So let me take you to some of the latest VMs that were launched and walk you through the options, right? So again, Stefanie mentioned the wide range of general purpose VMs that we have available in Azure right now with our 4th Gen EPYC and 6th Gen Azure instances. So starting from on the left side, you're seeing is your D series, which is the most utilized general purpose VMs. We have VM sizes from 2 vCPUs all the way from 96 vCPUs in that. It has options for low, medium, and low and medium memory up to 4 GB per core per vCPU. And then it also comes in with and without local storage. So really targeted towards your general purpose workloads, your web servers, your low to medium databases, some data analytics there, Java and business apps. So that's your D series. A lot of apps, a lot of workloads like the bigger, medium to bigger databases, they are very sensitive to the memory bandwidth because you can kind of really allocate more of the database into the memory. So that's where the EA series comes. EA V6, also powered by our 4th Gen EPYC Genoa. That is also from 2 vCPUs all the way to 96 vCPUs. It comes with the high memory capacity per core, so 8 GB per vCPU. And again, it supports both local NVMe and block storage, so you have options across. Depending on what your optimization points are, you can select these the right SKU that hits your TCO. In the last gen with Genoa, we introduced a new shape, which we called FA. It's more compute optimized shape, again with our 4th Gen EPYC. There are certain applications that absolutely are very compute intensive. So we co-engineered this with Microsoft, with the Azure team, with Stefanie and team to provide an option where it comes with the simultaneous multi-threading. Some of you guys know it as hyper-threading turned off. What that does is it gives you the core, the physical core, the full resources, and there's no noisy neighbor. And in certain applications where single-threaded performance, which is very compute sensitive, this is one of the best options. While it's priced slightly higher than the DAEA series, the performance you get for the workloads that you are targeting, really the perf per dollar, the TCO really is you get a lot of value out of it. Again, that comes with different memory options. And right now it doesn't have the local storage, but we are kind of fixing that in the V7. We are adding that feature later on for the V7 series that Stefanie is going to talk about. Now, beyond these DA, EA, FA, which is various different configurations of your general purpose VMs, we also have the storage optimized instance. This is full circle. We started our relationship with Azure back in 2017, where our first VM series that came out was LSV2. Now with the 4th Gen EPYC, we are on LASV4. So A is for AMD. So there are two shapes, LAS and LAOS. The LAS comes from 2 vCPU all the way till 96 vCPUs. And that is really targeted towards storage optimized use cases. So if you have big data analytics, it's very critical in some of the AI inference running on CPUs, where you can put a lot of data set into your local NVMe versus having to rely on block storage. So LASV4 and LAOSV4. LAOS comes in smaller sizes. What that does is gives you more local NVMe bandwidth and capacity per vCPU. Again, very critical for those big data analytics and AI inference kind of workloads. So starting from D, E, F, and L, we cover the gamut of general purpose, different memory shapes, local NVMe, without local NVMe, that is block storage, and then also the storage optimized shapes. a lot of our customers have taken benefiting from these wide range of VMs that are out there because one size does not fit all. A lot of workloads really require specific memory shapes, specific local NVMe. So we work very diligently with Microsoft in offering those at the best TCO. Okay. Obviously, those were just shapes. So I wanted to quickly cover some of the performance metrics. So if you look at this graph, what you see on the left-hand side is we are comparing our V6, which is the DA/EA V6 and FA V6, to the previous gen alternate x86 instances. And if you look at that DV5 versus DA/V6, we are 36% better performance per dollar compared to DV5. So if you were on an older generation V5 instance from an alternate x86 instance, migrating and modernizing rather to the latest DA/V6 can improve your performance per dollar by 36%. And the way we come up with this is not just one spec int number. A lot of benchmarking is around spec int numbers, but we really go and benchmark workloads from front-end workloads, from web servers, from Java applications, databases like MySQL and SQL Server, some of the very targeted workloads for certain verticals like video transcoding and encoding. So what you see here is a weighted average across all of these different workloads. Some of them are compute sensitive, some of them are IO sensitive, some of them are memory sensitive. So that's a geo mean or weighted average across all those workloads. Now, if you go from DV5, if your workload is really compute intensive, then going from DV5 to a FA V6, even though it's priced a little bit higher because of the performance, your performance per dollar improvement is about 50%. So that is, again, very curated, very targeted to workloads that require high performance per core by turning the SMT off. And again, we're also comparing on the right-hand side memory optimized instances. So you compare your EV5. So if your application is memory sensitive or memory bound, where you need 8 GB per core, if you were on a previous gen alternate x86 V5 instances, migrating and modernizing to the latest V6 will deliver 40% better performance per dollar compared to the previous V5 generation. So just some benchmarks just gives you an idea. What you do with all that savings, whether you are going for higher performance, with the same budget, you can get more compute sessions, or if you are trying to go, hey, with higher performance, I can get the same throughput in less number of VMs. That's where your savings come in. What you do with this savings is up to you. You bank it, you invest in innovation, you put it in your AI pilots, whatever it is. But the key takeaway from here is modernizing to the latest V6 instances, whether it's DA/EA or FA, depending on your workload, can save you anywhere from 36 to 50% or more in some cases, that you can go invest and fund your innovation. A lot of those benchmarks are just putting things into perspective. Like, let's assume you are an e-commerce company, and you're hosting an e-commerce website on Azure, and your front-end clients, and this is a simplified use case, but let's say you have enough front-end clients that you're generating, your consumers for your website, they're coming and they're driving traffic up to 20 million requests per second. So this is something like an Nginx or Apache web server. That's what the client-consumer interface is, right? That creates a business logic. You have your Java web server, which is hosting your e-commerce website. So it goes through those requests and kind of processes that. And on the back end, it pushes kind of reads and write requests to your databases. So let's assume that's a MySQL database. And this kind of use case that I've put up here translates to 40 million transactions per minute. So if you were using an older V5 instance, based on the benchmarking we have done for Java, for web servers, as well as for MySQL database, you would require about 12 VMs for V5 from an alternate x86 instance to handle your 20 million requests per second. You would need 30 VMs of EV5 for your Java servers, and then you'll need 54 VMs to handle 40 million transactions per second to your databases. And when you add all of that up, you need 96 VMs, and based on just the list pricing, that would run close to $1 million of OpEx spend. So modernizing to a V6 instance, based on the performance benchmarks I showed earlier, 36% for certain workloads, 49% for other workloads, instead of needing 12 VMs to get 20 million requests per second for your front-end Nginx servers, you can get the same throughput with just 7 VMs. And that kind of story follows, right, with Java and web and databases. And you can reduce the number of VMs needed to serve your end e-commerce customers from 96 VMs to 72 VMs. And the pricing for V6 on AMD is very similar to the old generation V5 from alternate x86. So when you do all that math, you can get the same throughput, the same work done at around $730,000. So you're basically saving 27% OpEx. And what you do with that 27% OpEx, again, a lot of the companies, wherever you guys work, right, really want to go modernize, get the savings, and invest in AI pilots. A lot of classic ML and AI workloads still run on CPUs. Large language models, both training and inference, obviously, we all know run on GPUs. But there are a lot of workloads, a lot of applications, classic ML like recommendation engines, which you see on the left-hand side, benchmark. And on the right-hand side, small language model, Llama inference for 7 billion parameter model. If you are if your CIO, if your CEO is coming and telling you to go build and infuse AI into your standard workloads, you can save that 27% you saved in the previous slide, you can really go put and run your AI pilots. And even running those AI pilots on V6 machines compared to the older V5 machines can get you anywhere from 50%, 32 to 50%, depending on what classic ML or inference model you're running on AMD versus the options. So the key takeaways, we all are going and figuring out how to infuse AI, but really it starts from how do you modernize your legacy infrastructure? If you're on-prem, migrating to cloud on these V6 instances. If you're an old V4 or V5 instance, migrating to the V6 instance really gets you that savings that you can go infuse and fund your AI pilots, again, which runs excellent on these general purpose VMs from AMD. V6 was the V6 VMs powered by Genoa, 4th Gen EPYC. I think they were launched in around November last year, close to around this time. It started with 6 or 7 regions, and in the past few months now, these are available in more than 50 regions. That kind of gives you an idea of the vast adoption we are seeing for V6s. In today's world, where space and power are come at a premium, getting these many VMs in across the regions really is only done if there is a lot of demand here. So we are in more than 50 regions. A lot of customers around the globe are using these V6 VMs. And here are some of like the profile of the customers from large research labs. They are using these general purpose VMs for data pre-processing and post-processing that gets fed into the AI training. They're using these V6 VMs at a scale that has never been seen before. We have enterprises from telco, from finance to retail using these V6 VMs all over the globe. Again, the adoption we are seeing on these V6 VMs powered by Genoa is faster than anything we have seen previously with V3s, V4s, or V5s. All right, to talk a little bit more about the adoption, I want to re-invite Stefanie back on the stage. Stefanie, all yours.
Thank you.
Thank you.
All right. Yeah, so we've had obviously many customers using these V6 AMD-based VMs, and several customers have given us feedback on the experience that they're having and the benefits that they've seen. I'll show this quote, which is from 𝗦𝗲𝘀𝗀𝗶, which is doing the rendering services, and they've been using the AMD 6 VMs, and they accelerated their workloads by 42% on average, while maintaining the low cost and high scale for their business. We also have Elastic, who has been using the LAO-SV4, which is a storage optimized VM, where they experienced up to 30% more throughput over the LSV3. So that is enabling a new option for Elasticsearch AI platforms offering on Azure. With Korea Telecom, they've been using the AMD V6 VMs for confidential computing, which helps protect their customers' most sensitive data and meets regulatory requirements. They use the V6 confidential VMs to maintain performance while also enabling the highest data protection with AMD's secure encrypted virtualization, secure nested paging, or SEVSNP for short. And it's not just external customers that have been adopting the VMs based on the 4th Gen EPYC. We have Microsoft and Azure SaaS and PaaS providers that are using these. And so if you're using services like Microsoft 365, Bing, or Microsoft Teams, you're likely running on AMD-based platforms. And major PaaS products like Azure Databricks and Azure Kubernetes Service have enabled 4th Gen EPYC, so you're able to choose this option if you'd prefer. And finally, major SaaS products like Microsoft Fabric, with over 25,000 customers, are enabling these VMs. And if you're using Microsoft Copilot, you also have AMD in the back end. So Azure Data Explorer is an example of a service within Microsoft that's been using the L-series VM across different generations. And they've been using it for big data analytics. And simply, their feedback is that the LAS v4 and LAOS v4 VMs have made their workloads more affordable. So going back to the Microsoft services list for a moment, I want to invite Mayunk Jain, who is a senior product marketing manager in the core AI team covering the app services for Azure. So tell us more about the announcements that you're making at Ignite and around the Azure App Service.
Absolutely. Thank you so much for having us, Stefanie. So I'm guessing this is more of a AI infrastructure crowd. Like before I begin, can I do a quick show of hands? How many of you have already used or heard of this product as your app service? Anyone? Okay, not bad. And another question, how many of you are aware of or are running maybe a sizable amount, I would say, of on-prem apps, whether it's .NET or Java? Not that I can see very clearly. Okay, so there's a good number, I would say, about maybe 25% of the audience. That's awesome. So my name is Mayunk Jain. I'm on the product team for Azure App Service, which is one of our PaaS services. And I'm really excited to talk about some of the work that we've been doing with AMD and Stefanie and Suresh's team. So if you've been paying attention to some of the announcements we've been making at Ignite, I first wanted to talk about something we've announced recently, just like Suresh was talking about. So the managed PaaS services run on top of AMD VMs, right? So all of the capabilities that he talked about, we abstract that away from the customer so that our customers are not really experts in managing infrastructure. They're just trying to run their .NET or Java apps in the cloud. That's all they want to do. So that's what App Service does. It abstracts it out, but under the hood, it does run on these VMs that we were talking about. So the latest VM the latest service plan that we announced is called Premium V4. So that comes with both the regular kind of VMs and also the memory optimized. So we call them P1 V4, for example, for the regular, and P1M V4 for the memory optimized. And it goes all the way from just a single GB of RAM or single vCPU all the way to like 256 GB of RAM and many vCPUs and stuff like that. So this is something that leverages the AMD DADS V6 and the EADS V6, and based on our internal tests, it delivers up to 59–60% throughput, better throughput over the previous generation. So that's a very big deal for many of our customers. And as Suresh was talking about, we all need to save money right now so we can spend it on AI. And this is a very important step forward where we are not only giving you higher performance, but we've been able to cut down the cost of the Premium V4 offering thanks to the cost efficiency of the platform and some of the changes that we have made on the service level as well. So just wanted to make sure that you guys are aware of it, and if you're interested in learning more about the Premium V4 service and how that really helps, that QR code will take you to a blog where you can learn more about it. But what I wanted to also talk about is a new thing we've announced here at Ignite, which is called Managed Instance on App Service. So a lot of our new investments are now going towards PV4. So that becomes a default landing place for most of the new things we'll be landing, and Managed Instance is one of them. And what is interesting about this is that, as I was asking you earlier, if you are still dealing with on-prem applications, if you're still dealing with a lot of code that is so ancient that you probably are not able to make changes to it, but you still want to run it in the cloud, Managed Instance gives you a way to respect those Windows compatibility, respect those dependencies, and then bring them on to a managed service like app service. So this is something that customers have been asking for a very long time. I'm very happy to announce it is in public preview now. That link, the QR code will take you to the blog that will help you sign up for the public preview. I mean, there's no sign up, you just have to, it'll give you the instructions to use the public preview. And this will then set you up on that path to success if you're trying to build more AI apps, you're trying to integrate it with some of the other cool things you might have seen at Ignite this week. So this is something very important, again, for our customers who want to be modern, who want to embrace the cloud, but they just have a lot of app estate that is very legacy, very ancient, and how do we get out of that? But that's just one part of what we've offered here today, right? So the other way we do it is for the customers that do actually have access to the source code, that may actually have a huge monolith application that they want to analyze, they want to assess it, and then make the required changes to move it to the cloud. But even that has been extremely painstaking. It's a very manual process. It takes a long time. And the other thing I wanted to quickly land with you guys is how are we leveraging the power of agentic AI to reduce the toil in that process, to reduce the time and reduce the cost in that process. So while it can be done, and we've been doing it, it just takes time. And now with a new thing that we've announced here called GitHub Copilot app modernization, we've cut that down from years or months to a matter of days and sometimes even hours. So this is what I wanted to just leave you with, which is this new thing, which is now GA. So it was public preview at Build, and now we are proud to GA it, called the GitHub Copilot app modernization that works for both .NET and Java applications. And it is able to, again, assess all your applications and in a very conversational, natural language interface. If you can see there in that demo screenshot, you can just say, hey, this is my app. Tell me what do I need to do to modernize it? What do I need to do to move it to the PaaS? And then it will assess it, give you a very neat report, and it'll go one step beyond that. It will actually tell you that here's what needs to change. And if you'd like, because we are integrated with the GitHub Copilot coding agent, it will say, if you want, I can make those changes for you. And in some cases, you'll be like, sure, go ahead and do it. In some cases, you'll be like, no, let me do it. Up to you, whatever your comfort level is with autonomous agents. But you have that control. You are always in control of what you want to do. But by the time you're done with that, you can really take a very legacy app, a .NET Framework app, a Java 7 app, and move it to something new like Java 21 or .NET 8 or .NET 9 or even .NET 10, and just have it running in the cloud. And it can run on the PV4 with the AMD, it can run on one of the VMs with the AMD, or it can run on any of the other services that we have in the cloud as well. So before I leave, I just wanted to give a quick shout out to some of our related sessions. If you'd like to learn more, the big one that I would highly recommend you try if this is interesting to you is a lab we are running at 2:45 today called the Lab 501. So that's the last one on the left side. So that's where you can get your hands dirty with the managed instance on app service. You'll get to actually see the AMD in action. And then we have a couple of other breakouts which have happened on Tuesday and Wednesday that you can find on demand. And on the right there, I have a few links to, again, the links that I shared earlier as well. How do you join the public preview? How do you find the product docs? And then if you want to estimate your PV4 spend, then we have a price calculator that you can use as well. So with that, I thank you for your time, and I'm going to hand it back to Stefanie. Here you go, Stefanie.
Thanks, Mayunk.
Thank you so much.
All right, so now let's talk about what's coming next for AMD infrastructure in Azure. So in preview, currently we have the Azure AMD-based V7 VMs on the EPYC 5th generation CPU. And we're going to be adding new options for our DA, EA, and FAS V7 VMs. So we'll be adding larger sizes, some predefined constrained core options, and for the single-threaded FA series, we'll have a new size down to 1 vCPU and as large as 80 vCPU. And we'll offer options both with and without local temp disk and the constrained core sizes. So these are in preview now in 3 regions. And so these are coming out very soon, and we have measured substantial performance gains across a variety of workloads compared to the V6 versions. You can see on the left, there's general integer intensive workloads. We expect up to 35% performance improvement. For Java-based workloads, we can see up to 25% performance improvement. And for applications such as memory and in-memory cache, we may see up to 65% improvement. And finally, for cryptographic heavy workloads, you may see up to 80% performance improvement. So these are some astonishing numbers, and we're looking forward to having these VMs available broadly very soon. I'd like to share another example of a benchmark. This is showing some code under test that's a Microsoft to-do application pulled from GitHub. It uses React.js, Node.js, MongoDB, and AKS. So this sample code is used to deploy 2 near identical environments. The only difference is the underlying AKS node on the left uses the Genoa-based D8ADS V6, and the deployment on the right uses the Turin-based D8ADS V7. So the load is applied to both environments using the Azure Load Testing Service, which is a fully managed service that allows you to simulate high-scale traffic for your applications. So after the test is completed, we can see that the V6 implementation on the left was able to process 33.56 million requests, while the V7 implementation was able to process just over 45 million requests. So this is a 34% improvement in the number of load requests in the same duration of time. We also see that in the V6 implementation on the left, that has a 90th percentile response time of 502 milliseconds, compared to 300 milliseconds for the V7 VMs, which is a 40% reduction in response time. So this is just one example, but we're very excited to see how our customers will experience the performance improvements for their workloads. So now I'll hand it back to Suresh to help us finish things up for today. Yep, thank you.
All right, great numbers, Stefanie. Thanks for sharing those. Those don't happen by happenstance, right? We go spend a lot of time when we go from gen over gen to look at like how do we improve the IPC, how do we improve the frequency, how do we improve the connectivity at a CPU level. But at the same time, we work closely again with Stefanie's team on at a platform level, what all things we need to do, right? Things like how do we make it economically possible to offer a 1 vCPU FA instance, or how do we add local NVMe to make sure that if you have a beast of a core, how do we feed into that core so your overall performance for your workload really is uplifted? So there's a lot of co-engineering that happens. Something that we launched today together, the work on that from a co-engineering perspective had started happening, innovation started happening 2 or 3 years before that, before you even see these things. A lot of work that goes into this. Now, Stefanie talked about a lot of general purpose workloads that we are seeing up to 80% performance uplift. And that is critical because for every gigawatt of AI capacity that is deployed, you need about 200 megawatts of general purpose capacity, because you need a lot of pre-processing, post-processing, serving those models. There's a lot of general purpose compute involved in that. And as a lot of customers are already using these instances, a lot of their AI workloads where it's small language model, or it's a similarity search, it could be classic AI ML, or it could be really small language model, that could run very efficiently on CPUs. You guys as customers have bought capacity into Microsoft, into Azure, and if you can leverage the same infrastructure to go drive your AI workloads without having to really go unless it really requires it, unless it's a large language model, unless you have a lot of concurrent users, you need GPUs in those cases, obviously, and we have great options on GPUs too. But a lot of the use cases with small language models and classic AI/ML, as I mentioned earlier, could be served very efficiently through your existing CPU commits that you have on Azure already. So what I'm comparing here, Stefanie went over on some of the general purpose workloads, V5 versus V6. What I'm comparing here is, V6 versus V7. What I'm comparing here is V6 versus V7 specifically for AI inference running on CPU on V7 instance. So in purple, pink, whatever you see on the screen there, that's our V6 powered by 4th Gen EPYC. And in blue, you see the latest V7 that Stefanie just announced. So you're seeing for your Llama 8B token served, and we've also invested a lot on BF16 flops in our Turin generation, which is powering. So you see the effect of that in all of these workloads. So if you look at Llama 3.1 BF16, we're seeing up to close to 40% better inference throughput served via VLLM inference engine in V7 versus V6. Similarity search is critical in a lot of verticals like e-commerce and such. So you're seeing up to 86% better performance compared to your V6s. And then for XGBoost for machine learning, you're seeing a more than 100, almost 2x performance uplift compared to V6. So just wanted to share that these VMs, V7 VMs, are obviously great for all your general purpose workloads like web servers, MongoDB, Java, video encoding, transcoding, but they are excellent value even for your AI inference workloads. So with that, this is my last slide. I promise I'm person standing between you and lunch. I'm going to go quickly. Some of the sessions, related sessions that you could benefit from are listed here. More information about V7 instances, about AMD's AI solutions in Azure, and app services that Mayunk went through are also listed as QR codes. I'll leave it there if you're interested in snapping that. But yeah, I think that's it. Thanks a lot. I mean, key takeaways, I'm going to not repeat it. Just go try out V7. If V6 is available in your region, modernize to that. There's a lot of benefit in doing so that the team explained here. With that, I think that's it. Stefanie, Mayunk, if you want to come back over. Any questions, we'll be happy to take. If you just want to come over to the mic, that would be helpful. If you are mic shy, we'll be hanging around for a bit here, and you can catch one of us on the side. Either ways is okay. Yeah.
Well, you mentioned the big LLM models and GPUs. Can you develop a bit these parts as well from AMD perspective? Because I understand now the smallest one and the machine learning models, they can be run on CPU optimized. What if I have a big one and I want to run it? What's the state of arts today?
Not sure if I fully caught it.
I don't think I caught quite. What was the beginning? Yeah.
Yeah. Maybe.
Well, the big LLM models, they still run on GPUs today, right? You don't have any option on the CPUs optimized whatsoever it is?
Yeah, so there is typically we're seeing up to, and we're talking about inference here, so we've seen up to 15, maybe even 20 billion parameters, which kind of gets into the medium language models, especially with our latest Turin instances where we have more BF16 and we are in next generation going to put more FP4s. You can get up to that, right? Beyond that, you're going to get to the GPUs, like over like 15 to 20 billion parameters. You really, I mean, not that you cannot run on CPUs, it just will not be your TCO. You won't get the same TCO and performance as you would get with the GPUs.
Okay, and the concurrent accesses is also managed through GPUs, or you can be parallelized with the CPUs? Yeah,
so typically the CPUs will, from concurrency, if I understood your question correctly, the concurrency standpoint, we obviously go and test all the way to 2,000 to 4,000 concurrent users. So I don't want to quote a wrong number as to what is the threshold beyond which, like if you have so many concurrent users, you have to go to the GPUs. but I suspect, don't quote me on that, it's probably somewhere in the 256 concurrency range.
Okay, thank you.
Yeah. Okay. No more questions on the mic. Feel free to reach out to us here. Thank you so much for being here. Appreciate it.
Thank you.
Thank you.
Thank you, Stephanie. Thank you, Mike.
Thank you.
Thank you.